Hello friends, myself Rajendra Mahajan presenting my video on area by double integration. Let us solve the problem. Find area by double integration between two curves y square is equal to 4x and second line 2x minus 3y is equals to minus 4. And to obtain that area, first step is to draw the two figures. The first one, y square is equal to 4x, is the parabola symmetrical to x-axis passing through origin. Therefore, that curve I have shown this way, y square is equal to 4x. And to draw that second line, we require two minimum points. Put x is equals to 0, we get minus 3y is equals to minus 4. For x is equals to 0, we get minus 3y is equal to minus 4, means y is equal to 4 by 3. Therefore, when x is 0, y is 4 by 3, 1 point something. Therefore, this point I have shown by red color. That point is 0, 4 by 3. And for y equal to 0, we get 2x is equal to minus 4, means x is equal to minus 2. Therefore, when x is minus 2, this point, y is 0, means it is on x-axis. Therefore, joining these 2 points by means of straight line, we get that line whose equation is 2x minus 3y is equal to minus 4. Okay. And then the region between these two curves, therefore, this is that region. Suppose if we call this as point A and this as point B. This straight line, and then from this point to this point on the parabola. Therefore, we require this point of intersection, and this region is called as the feasible region or the region of integration. And to obtain the limits, we have to obtain the point of intersection of that two curves. Therefore, that two curves are y square equal to 4x, and second one is 2x minus 3y is equal to minus 4. Solving both the equation for x, from this we get x is equal to y square by 4, and from this we get 2x is equal to 3y minus 4, and x is equal to 3y minus 4 divided by 2. Then equating these two values of x, y square by 4 is equal to 3y minus 4 by 2. That is, transferring this y 4 to right hand side, we get y square is equal to 4 multiplied by 3y minus 4 by 2. Dividing by 2, we get y square is equal to 2 times 3y minus 4. That is nothing but, transferring all terms to left hand side, we get y square minus 6y and minus 8. When we transfer to left, it becomes plus 8 is equals to 0. We get quadratic equation in terms of y. Then solving this for y by making factors of this 8. Sum must be minus 6 and product must be plus 8. Therefore, factors are y minus 4 and y minus 2 equal to 0. Sum is minus 4 and minus 2, that sum is minus 6, and the product of minus 4 and minus 2 is plus 8. This gives you, that is, equating it to 0, we get y is equal to 4 and y is equal to 2. Substituting this value of y for y equal to 2, we get 3 to the 6, 6 minus 4, 2, 2 by 2, we get x as 1. Therefore, point is 1, 2, and when y is 4, we get the value of x as 4 square, that is 16, 16 by 4, we get 4. Therefore, that point is 4, 4. Therefore, we have to show this in this figure. Therefore, the first point of intersection is 1, 2. When y is 2, we get x as 1. And second point of intersection is when y is 4, we get x as 4. Therefore, these are the point of intersection of that two curves. Okay. Then we have to shade the region between these two curves. I will shade that region. Between these two curves. Then, to perform that double integration, we have to draw the strip either parallel to x-axis or parallel to y-axis in this region of integration. Here I am making a strip parallel to x-axis whose lower end is on parabola and upper end on that line. Okay, and therefore, as the strip is parallel to x-axis, your first integration is with respect to x, and that strip is called as elementary strip. As elementary strip is parallel to x-axis, we have to integrate first with respect to x. Between limits x is equal to 2, x is equal to. How to get that limits? With the help of the ends of that strip. As already I have mentioned, lower end lies on this parabola whose equation is y square equal to 4x. Solving it for x, we get x is equal to y square by 4. That is the lower limit. X is equal to y square by 4. And other end lies on this line whose equation is 2x minus 3y is equal to minus 4. Solving it for x, we get x is equal to 3y minus 4 by 2. X is equal to 3y minus 4 by 2. Therefore, these are the limits of x. And then integrating that result means result of first integration with respect to y by moving the strip throughout that region. Therefore, we have to take that strip where the region starts and we have to move it up to where region ends. Therefore, this is one line and we have to take it up to this line. Therefore, and we move in upward direction. Therefore, at this the equation of that line is y equal to 2, and here it is y equal to 4. Between y is equal to 2 to y is equal to 4, and therefore we put these limits. We have to obtain the area, and the formula for area is double integration of dx dy. Here we are integrating first with respect to x and then with respect to y. Limits for x are x is equal to, lower limit is y square by 4, and upper limit is x is equal to, that equation is 3y minus 4 by 2, and then whatever the result of this integration is integrated with respect to y by moving that strip between y equal to 2 to y is equal to 4. And if we evaluate this double integration, whatever the value we get, that value represent the area of that region between that two curves, a parabola and that line. And therefore, performing the calculation, all of you are knowing how to evaluate the double integration. Outer integral I am keeping as it is 2 to 4. Integration of dx is x, limit from y square by 4 to 3y minus 4 by 2, and whatever the value, then we have to integrate it with respect to y. Substituting the upper and lower limit, therefore integration from 2 to 4 as it is. Upper limit for x is 3y minus 4 by 2, dividing separately by 2, and minus lower limit is y square by 4, and then this we have to integrate with respect to y. Integration of this y is y square by 2, therefore that 3 by 2 constant term as it is we take outside. Integration of y is y square by 2 minus 4 by 2 means 2, and integration of dy is y, and minus integration of y square is y cube by 3 and that previous 4, therefore it becomes y cube by 4 3 is 12, and limits from 2 to 4. Either we can substitute the upper limit first and then minus lower limit, or we can go term wise, upper minus lower for first, upper minus lower for second, and upper minus lower for the third term. Here I am making a term wise. Therefore, we get this one as 3 by 4 multiplied by upper limit is 4 for y, therefore 4 square is 16, minus lower limit is 2 square is 4, therefore 16 minus 4, minus 2 into upper limit for y is 4, lower limit is 2, and minus 1 by 12, upper limit cube 4 cube is 64, and minus 2 cube is 8, and then simplifying it further, it is 3 by 4, 16 minus 4 we get 12, minus 2 into 4 minus 2 we get 2, and minus 1 by 12, 64 minus 8 we get 56, and again simplify it. 12 by 4 we get 3 3 is 9, minus 2 to the 4 and minus 56 by 12. We keep that as it is. Okay. 9 minus 4, we get 5. Minus 56 by 12. Cross multiplying it by 12 or finding LCM, we get 5 12s are 60 minus 56. 60 minus 56 we get 4 and divided by 12. Therefore, the value is, dividing by 4, we get 1 by 3 as a required area. And we write down, as it is the problem of area, the unit is square units. As it is the problem of area. And therefore, we get the value of area as 1 by 3 square units. And this is obtained by performing the double integration. Important step is the figure. Therefore, we have to draw this figure by drawing that two curves. One is the parabola symmetrical to x-axis passing through origin, and the second is the straight line whose equation is 2x minus 3y is equal to minus 4. Then we find the point of intersection of that two curves. The first point of intersection we get as 1, 2, and second point of intersection we get as 4, 4. And then the region between these two, straight line and parabola, that region is called as a region of integration, over which we have to perform that double integration to obtain that value of area. And whenever we require to perform double integration, either we have to draw the strip parallel to x-axis or parallel to y-axis. Whatever you want, you can draw. Here I have drawn it parallel to x-axis, and as it is parallel to x-axis, first integration is with respect to x and then with respect to y. Yes. And then after getting that limits, perform that double integration. As usual, we are obtaining the value of double integration. Simplify it to get the value as 1 by 3 square units. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.